Okay, now I think we should start working on this problem. So it's similar to a previous problem that we have done. So in the first second, see the important thing is here we have to see that it starts from rest. Okay, it starts from rest. Okay, that is to be taken into account. So therefore, our equation for this should be in terms of sign, right? So if we take the amplitude as A, then we will write it as A is equal to A sine of omega. That is in the first second. And in the second, it is going to have B, and therefore the total distance that it has traveled will be A plus B is equal to A sine of 2 omega. So quickly we can write this as 2A sine omega cos omega. And then we can quickly substitute this as A sine omega. We can write it as A. So we can write it as 2A cos omega. Cos omega we write it as 1 minus sine square omega. Okay. So then it's just a matter of substitution. So root of 1 minus A square by E square. Okay, and rest of the things are manipulations that follow. So we have to filter out A. So therefore, we will do it like this: A plus B whole square is equal to 4A square into 1 minus A square by A square. Okay, so this implies that A plus B whole square by 4A square is equal to, okay, we will quickly do the analysis here. So 4A square will come down here, and I have to push this here. So I can write this as, A square by A square will be equal to A square by A square, because I have pushed this A square here and this here. So this will be 1 minus A plus B square divided by 4A square, and so this can be written as 4A square minus A plus B square divided by 4A square, and that is, we want A square. So we get here A square is equal to, if I push this A square by A square, then this gets inverted. So this becomes 4A4 divided by 4. So 4A square, I can open the bracket here.
Minus B square minus 2A.
Yeah, what will be 3A square?
Minus B square minus 2A.
Minus B square minus 2AB. Alright. So this is going to be the thing. So here you will take it as A is equal to 2A square divided by, this is not a perfect square, right? So 2A square is the numerator that we have got. So here we are getting it like this: 3A square minus 2 square minus 2AB. Well, I don't see the option here even in this way, but this is close to this option here. Okay, hello?
Sir, one this thing, sir, when we are using sine function, sir, the phasor, like at 0, you will consider it vertically upwards. This
vertically upward means?
Rotating vector, it will be pointing towards north direction. Sir.
No, it will be pointing towards east, and you are taking its projection on the vertical axis. You
Yes.
are taking it
Okay.
like this.
For sine, we will do that.
We are taking
But sir, if we are doing it with cos, then we can.
Yeah, it will be ulta. Okay, it will be ulta. Now don't complicate it. Now here, have you gone wrong somewhere here? I don't think so. We have gone wrong anywhere here. So this should be the thing. This should be the thing. Okay, we'll settle down for this. We'll not spend more time on this. So this is the answer, and we don't see that option here if they have marked this option wrong here. Okay, they mark this option wrong here. This should be root of this. Root of this. Okay. Hello, we'll set it down for this. We'll not waste time on this. Okay, shall we proceed?
Yes, sir.
Yeah, please.
Yes.
Okay. A particle is subject to two mutually perpendicular simple harmonic. See, you have to mark every word very important. Mutually perpendicular simple harmonic motions. Okay, such that x and y coordinates are given by so and so. So try to understand this problem first. Is subjected to two mutually perpendicular simple harmonic motion. That means it is acted upon by two forces which are perpendicular to each other, mutually perpendicular to each other, and they are acting on the same particle. I hope you understood the situation. So usually if you have a particle, it is say a mass and a spring. So it oscillates like this. So the force is along this. Now to this particle, supposing you have another spring tied like this, okay, and then you disturb this particle. So it is being acted upon by two forces, one like this and one like this. Okay, subject to mutual simple such that its means the resultant's x and y coordinate. The resultant's x and y coordinates are like this. See, you get hold of the problem. This particle is subjected to two forces, one like this and one like this. Okay, that is, the forces are along this direction. Okay, I hope you understood this. The forces like this along these two. So therefore, the resultant of the two forces is something. Hello, are you with me?
Yes.
Okay, now assume that at a particular instant of time, this particle is pulled by some force like this and also some force like this. So its resultant is going to be this. Okay? Hello, are you with me?
Yes.
So now it's x component. So it's x such that the x and y coordinates. So the x coordinate of this and the y coordinate of this is what is 20. The x coordinate of the resultant is given as 2 sine of omega t, and the y coordinate is given as 2 sine of omega t plus pi by 4. So they are asking you whether it's an ellipse, a straight line, a parabola, or a circle. So let us look at it like this. So if it is to be a circle, then it should be x square plus y square is equal to some constant. I mean, you should get this expression, correct?
Yes.
Hello? And if it is a parabola, then we should get it as y is equal to some constant k x square plus, sorry, ax square plus bx plus c. We should get it like this. And if it is a straight line, we should get it as y is equal to mx plus c. And if it is an ellipse, then we should get it as x square plus y square minus 2 root 2 xy is equal to some constant, correct? correct me if I am wrong.
Yes, that is the.
For ellipse, correct me, yeah? You are better in mathematics, okay? So we should see whether we are able to get these expressions.
Ellipse, it will be the last ones.
Ellipse. So here I think we should open this up. So if you open this up, we are going to get
X square plus y square minus root 2xy equal to 2.
So if you open this, we are going to get, and then only we will get an andas, no? If you open this, so sin omega t, sin a plus b, sin a cos b, right?
Yes, and then we can write.
So sin a cos b, you will write it as cos b cos pi by 4 will be 1 by root 2. So that will be now 2 by root 2 will be root 2 sin omega t, okay, plus cos a sin b. So it will be again root 2 cos omega. Am I right? If you open this up. And now if you see x square plus y square must be constant, I don't see that happening. And
we can further simplify it, sir.
Yeah, further simplify in what way?
Sir, you can write it as 2 sin omega t by root 2.
What will you get? What will you get? Okay,
2 sin omega t you can write as x.
This one, 2 sin omega t, I am writing it as x, yeah.
Y equal to 2 sin omega t plus root 2 cos omega t. From that we can write y equal to x by root 2. Then that cos omega t we can write as 2 into root over 1 minus sin square omega t. We can take 2 inside common, sir. Then we can write root over 4 y root 2 equal to x plus root.
No, why should we do all that? Why should we do all that? Why should we do all that?
The equation we will get, sir.
No, why should we do all that to get it? No, I'm just saying my instruction. See here, x square plus y square, can it be a constant? I don't see it's going to be a constant. Right? Okay, I don't see that is going to be a constant. So this is ruled out. And can we get here y is equal to ax square plus b? I don't see. By inspection, this is also not possible, and this is absolutely not possible. So only possibility is this. So I would go for this. I would go for ellipse. No doubt. By inspection, I would go for the ellipse. But if you want to prove that, then I will go with you. Come on, tell me, Mr.
So, y equal to we can write it as sin 2 sin omega t by root 2.
Wait. This already I have written here. Root 2 sin omega t, root 2 cos omega t. What should I write here?
You write 2 sin omega t by root 2.
2 sin omega t by root 2. By root 2 means I can. Okay. You want me to write it as?
So write it as by root 2, please.
Okay. You want me to write it as? To write it, what should I write here?
2 sin omega t by root 2. You should write.
Okay. 2 sin omega t by root 2.
Then plus 2 into root over
root
1 minus sin square omega t.
1 minus sin square omega t. Okay.
The whole thing by root 2.
This should be root 2 down here.
Yes, sir. Now on top and bottom, you write 2 in top and root 2 in the bottom.
Okay. You want it to stand. Okay.
Then that root 2 you can take on the left hand side, so you can write y root 2.
Okay. So we want me to write like this. Fine. Shall I write it as root 2y?
Then that 2 sin omega t we can write it as x.
2 sin omega t you can write it as x.
That 2 which is there in the numerator for the second term we can take it inside.
We can take it inside this one. Inside
the
the
root, and then we can write as 4 minus 2 sin omega t whole square.
2 sin omega t, 2 sin omega t whole square. Okay.
Again, sir, we can write 2 sin omega t as x.
X plus root of 4 minus x square.
Yes, sir. Then you would take this x on the left hand side, sir. Root 2y minus x you do it times.
Minus x. Huh.
And then you square on both sides.
So square on both sides. And
Yes.
open the bracket. You want me to open the bracket?
Yes.
Plus x square minus 2 root 2xy equal to 4 minus x square.
If you take it on the left hand side, so you will get 2y square plus 2x minus 2 root xy equal to 4. 2 you get
minus 2
2xy.
xy is equal to 4. Right?
2 you can cancel throughout the equation.
2 you can cancel. You can get it as x square minus root 2xy is equal to 2. Okay, good. Thank you. So it's confirmed that it is an ellipse. Okay, fine. I hope everybody is comfortable with this and happy. Thanks, Abhinav, for making sure all the mathematics works. So I want solutions to come from you. It's not that I want to do it, and it's very important that you get it right. If you involve, if you solve, you will learn. If I solve, I don't know what you will learn. Okay, so please make it a habit. Thank you. Right, shall we proceed?
Yes.
See, it's full of science and logic, so both of them will be strengthened. You practice these such problems. See, you at every point, you must ensure that your brain is getting more and more power. Your brain is becoming more powerful with a lot of science, skills, okay, and logic also is growing. Okay, fine. Solve this. The period, it's in the mean position. Small extension of the previous problems.
Yes. Option B.
Option?
B.
See, now today I found, 7:31, many students had not logged in. This is very bad. See, when I say 7:30, 7:25, you must be ready. That's hallmark of good students. You see, these small things, matter. Somebody else?
Yes, C option.
Somebody got C option.
Yes, I also got C option.
But somebody was in a hurry. So 2 students have got C option.
Even I got.
Now, the most important thing is, here they have not said it is simple harmonic motion. Have they? They only told it is having a period. That means it's a periodic signal. Okay, it's a periodic signal. They are not told it is simple harmonic motion. So be careful about that. Okay, now at t is equal to 0, it is in the mean position. Okay, they are not even told it is equilibrium. See, if it is a free oscillator, then mean position and equilibrium positions will be same. Otherwise, it will be different. So I'm just telling you, these are the things that you should watch out. The ratio of the distances covered by the particle in the first and second second. Right. So here, what will you do? Will you take it as a simple harmonic motion or periodic motion?
So we can take it as a periodic motion, sir. With sinusoidal or cos functions, if we take, sir.
No, wait. If you take sinusoidal and cos, then it will be, then you are considering it as simple harmonic. See, simple harmonic motion is periodic motion, but all periodic motions are not simple harmonic motions.
Yes.
So first of all, you have to establish that. See, what I mean is now, well, if it is simple harmonic, okay, it's going
They have given it as periodic, sir.
So
it has to satisfy for the periodic, it should also satisfy for simple harmonic.
Simple harmonic also, correct? No? So simple harmonic motion will be one special case of periodic. So you can solve it for that. Okay, right? Okay, in this numerical, fine. You can assume like that, and you can do that. But
what if it is only periodic motion?
Wait. Then things are going to be slightly complicated. Okay. So now I'm just highlighting this. Okay. See, it's not about just solving this numerical and getting away. We have to learn this, right? Now you see, for example, this can be a periodic signal with same period, I suppose. Okay, that is this continuing on both sides. So if I go with this signal and this signal, then you see the ratio of the distances covered will be different. Okay, if you take this waveform, it will be different. If you take this waveform, it will be different. So, but the problem says, that it is unique. So therefore, I will not take it as simply periodic. I will take it as periodic with simple harmonic. Okay. Otherwise, this problem will not be satisfied. I suppose you understood. Hello. Understood? See, that is how you have to conclude. Of course, it's not necessary here, but some other numerical, this can be an essential feature. Okay, so going by this, I think it is an extension of the previous problem. So it was A is equal to in the rest position, it is equal to in the mean position. So we are going to write A sin omega and A plus B, we are going to write A sin of 2 omega. The same thing we did there. So this becomes 2A sin omega cos omega and A sin omega we are going to write as 2A cos omega. Right. So they are asking you the ratio of the distances covered by the particle in the first and second second. Right. So therefore, first and second they want it as A divided by A plus B. Right. So A divided by A plus B, we are going to write it as. Correct. Am I doing the right thing, students? Hello.
If you do the other way, it will be.
Other way means?
A plus B by A.
The ratio of the distance covered by the particle in the first second and the second second.
The ratio we can invert, sir. It will be easier to calculate these things.
Ratio, if you do it, it will be easy to calculate. Okay, I'll go with you. So, go with A plus B by A. Okay, tell me.
So that will be equal to 2 cos omega, if we simplify.
Yes, that will be because you are going to cancel these two, no? Right.
Yes.
Okay. Fine, I'll go with you.
So omega is 2 pi by t, sir.
Yes, 2 pi by t. So, right. So 2 into cos of 2 pi by t. Correct.
2 pi by 8.
2 pi by and 2 pi by 8. Right. So it is pi by 4. So that becomes 2 by root 2 becomes root 2. Okay. Then you have this.
Left hand side we can write 1 plus b by a, sir.
That's it. 1 plus b by a. You have to open the bracket and say 1 plus b by b is equal to root 2. So therefore the next step will be b by b is equal to root 2 minus 10, and therefore the inverse of that is b by b into 1 by root 2 minus 10. Okay. Yes, C is the right option. Okay, done. Shall we proceed?
Yes.
Yes.